In this problem, we are asked to fill in the highlighted blank. This problem is a continuation of problem number 2. We are starting with an equation in standard form, and we are completing the square in order to rewrite this in vertex form. Here we have an a value of 3. So in the previous problem, we had to take that 3 and factor it out of our first two terms. Because when we have an a value of 3, we're saying we're going to make 3 squares. When we do that, we're going to divide our x squared big blue tiles and our x bars into 3 groups. So algebraically, that is factoring out the 3 of those first two terms. We just took our little unit squares, the small squares, and pushed them aside for a moment. Then in the previous problem, we figured out how many of those little unit squares we would need to complete each one of those 3 squares. And we did this by taking b and dividing it by 2 and squaring it, and we got 9. So for every square that we're trying to build, we need 9 little square unit tiles. But we're trying to build 3 sets of these squares. So that is saying that we would need 27 of those little square unit tiles. So when I added in this 9, that's just for one of the squares. I've really added in 27 for all 3. So that means I have to subtract 27 because I have to use the distributive property with this 3 to this 9. And in order to maintain equivalence with the equation we started with, we have to subtract the 3 times the 9 value.